Hey guys, Mr. Backerberg here. In this video, we're going to take a look at limits. Now, a limit is a pretty fundamental idea in calculus. Now, let's say we've got some function f of x. If our f of x function gets arbitrarily or infinitely close to a specific number, which we're going to call L, that's going to mean our limit, as our x value approaches a certain constant from either side, either the left side or the right side, then we would say that the limit of the function as x approaches that c is the limit, or the L value. So we write that out as the limit of our function as x is approaching some specific c number. Whatever number our function is approaching, that is the limit L. Now we're going to start taking a look at limits using a table to help us out. So let's say we had the function f of x equals 3x minus 2. What I want to do is I want to take the limit of this function as our x value gets closer and closer to 2. So we don't know exactly what's going to happen at 2, but what we want to do is we want to approach 2 from each side, getting closer and closer to see if our function is approaching a specific number. Now let's think about, on a number line, numbers to the left of 2. And I want to use numbers that are going to get really, really close to 2. So I'm going to start with using 1.9. And what I want to do is I want to take that 1.9, plug it in for x, and see what my function is equal to. So if I type that into my calculator, 3 times 1.9, but then subtract 2 from that, I get 3.7 as that y value, or as that function value. But I want to keep getting closer and closer to 2. So maybe for my next value, I use 1.99. So then I would plug that into my function, 3 times 1.99 minus 2, and I get 3.97. Well, I want to get even closer to 2, so maybe I use 1.999. And again, I plug that into my calculator, 3 times 1.999, and then subtract 2 from that, and I get 3.997. Now, I also want to look at what happens as we approach 2 from the other side. So maybe we start at 2.1, and I plug that into my function. So 3 times 2.1, but then subtract 2 from that, I get 4.3. But again, I want to get closer and closer to 2. So maybe for my next value on the right-hand side, I plug in 2.01. So 3 times 2.01, but then subtract 2 from that, I get 4.03. And then lastly, I want to get even closer to 2. So I'm going to go 2.001. So I plug that in, 3 times 2.001, I subtract 2 from that, and I get 4.003. Now what I want to look at is I want to look at what's happening to these y values, or function values. As I get closer and closer to 2 from each side, it appears as if my function is approaching 4. So I would say that the limit of this function as x approaches 2, I'm going to guess that that limit is 4. Now on this function, we could actually do something called direct substitution, where we take that number that we want to approach and actually plug it in. 3 times 2 is 6, minus 2 is 4. So it does appear that the limit is actually 4. But not every function allows you to do direct substitution. So in this example, we're going to look at the limit of this function as x approaches 0. Now I said some limits you can do with direct substitution, but this isn't a limit that's going to work this way, because if I try to plug in 0 for this function, I'm going to use my store key on my calculator. So if I take 0 and store it as x, and then type out my function, I get something that's not an actual number. It's not a real number. We end up getting 0 on the bottom of that fraction, so that's an undefined value. So I can't do this one using direct substitution. So I have to approach that 0 from each side. So I'm going to start left of 0, and I'm going to start with negative 0.1. And again, I'm going to use my calculator, and I'm going to store key this. So when I plug in negative 0.1, I get about 1.95. Well, let's move a little bit closer to 0. So maybe I do negative 0.01. And again, I'm going to use my store key there. And so when I type that in, I get 1.99. But then I want to get even closer to 0. So maybe I go negative 0.001. And again, using my store key there, I get 1.999. Now I also want to look at what happens from the opposite side. So instead of using negative 0.1, maybe I use positive 0.1. And I'm going to use my store key again. I do that and I get about 2.05 as that answer. But I want to move closer to 0. So I'm going to go 0.01. And then using my store key, I end up getting 2.005. But then I want to move even closer to 0, so 0.001. And I'll use my store key there as well. And when I do that, I get 2.0005. So as we look at what's happening as we approach 0 from each side, even though I can't actually plug in 0, it looks like my function is getting closer and closer to 2. So I would say that this limit, as x approaches 0, I would say that this limit is equal to 2. That's going to be it for this video. Thanks for watching.